Most people who worry about getting flagged for multi-accounting obsess over canvas hashes and the user agent string. Those are the easy ones to fake because they're just software values you overwrite. What actually trips up a lot of setups is something quieter, the readings a browser can pull off the actual physical hardware it's running on. And that layer is a lot harder to fix with a config file because it's not a string, it's a measurement. I run real proxy infrastructure and cloud phone farms, and testing anti-detect browsers against real multi-accounting workloads is basically my day job. I've watched setups that look flawless on paper, right IP, right time zones, right geolocation, get caught out because nobody checked whether the sensor data behind the scenes told the same story as the rest of the profile. So let's define the term first. A hardware sensor fingerprint is the combination of readings a browser can pull from motion sensors, light sensors, audio hardware, GPU drivers, and CPU and memory reporting APIs, then folded in alongside canvas and font data to build one composite picture of the machine sitting behind that browser tab. The reason this layer is harder to fake cleanly than canvas or fonts comes down to where the values originate. A canvas hash is generated by software rendering a shape and reading back pixels, so a tool can intercept that call and hand back a slightly different set of pixels. A lot of these hardware values come from a driver talking to a physical chip, and faking them well enough to survive scrutiny means simulating an entire chip's behavior, not just swapping a string. Device orientation and device motion expose accelerometer and gyroscope data, sometimes a magnetometer too. A real phone in someone's hand, or even just sitting on a desk, produces a constant stream of small noisy values as it's nudged, breathed near, or set down unevenly. A desktop virtual machine has no chip to report from, so it has nothing to say, and that silence, when a profile claims to be a phone, is itself a tell worth noticing. Light sensors work the same way underneath. The ambient light API reports lux values pulled from an actual physical sensor. Most phones have one built in, most desktops don't. So whether a light reading shows up at all tends to line up with what kind of device is supposedly running the browser in the first place. Then there's the coarser hardware reporting. Navigator, hardware concurrency reports the logical CPU core count, and Navigator device memory reports roughly how much RAM the machine has, rounded to a power of 2. Neither one is precise on its own, but both are real numbers pulled from the actual process running the browser, not something typed into a settings field by a person. Navigator. Max touchpoints tells a script how many simultaneous touchpoints the device supports, and that alone is a strong signal for phone versus desktop. A profile claiming to be a touchscreen phone that reports 0 touchpoints is already contradicting itself before a detection script even looks at anything else. The GPU adds another layer entirely. The WebGL renderer and vendor strings come straight from the graphics driver stack, and they name the actual hardware doing the rendering, or the software rasterizer standing in when there's no real GPU behind the browser at all. These strings are specific enough to name a chip family, not just say generic or unknown. Audio hardware gets fingerprinted too, and this one surprises people the first time they hear about it. An audio context test runs a signal through an oscillator, a compressor, and an analyzer node, and the floating point values that come back depend on the specific audio hardware, the drivers, and even how that particular CPU rounds numbers during the calculations. It sounds like an odd thing to fingerprint, but it's remarkably stable and repeatable per machine. Round all that out with screen and media device enumeration, so screen size, color depth, pixel ratio, and the list of camera and microphone device labels and counts a browser can see. A profile claiming to be a modern phone that lists 0 cameras, or a desktop that suddenly lists a front and back camera pair, is another quiet mismatch sitting there for anyone who checks. None of this is hidden or exotic, to be clear. Every one of these APIs exists for a legitimate reason: games that respond to tilting a phone, video call apps that need to know what microphone is plugged in, sites that adjust layout density to screen size. Fingerprinting scripts just read the same values everyone else reads for a different purpose than the one they were built for. On its own, any single value here carries weak signal. Plenty of laptops report 8 cores and 8 GB of memory, so that one field alone tells a detection system almost nothing useful. What actually matters is stacking all of it together: core count plus memory plus the GPU string plus the audio hash plus screen metrics plus touch points, evaluated as one combination rather than as separate isolated facts. A detection system doesn't need any single signal here to be unique to you personally. It just needs the full combination to be unusual, or to repeat identically across a batch of accounts, to get flagged for a closer look alongside whatever network and behavioral data it's already collecting on the session. That's the exact same logic Canvas fingerprinting runs on, just applied to a different set of APs. And it's harder to normalize away here because real devices are supposed to vary on these fields. Here's the part that actually catches setups out in practice, and it's about groups, not individuals. A batch of profiles that all report the exact same core count, the exact same GPU string, and the exact same audio hash doesn't read like a group of different real users on different machines. It reads like a template stamped out from one source, and templates are precisely what clustering-based detection is built to notice. The failures I see most often when I actually test tools aren't about one wrong value, they're about inconsistency between subsystems that should agree with each other. One common pattern is a profile claiming a mobile user agent while its motion sensors report flat 0, indefinitely, with no jitter at all. A real phone, even sitting untouched on a desk, produces small continuous noise from the sensor itself. Total silence from a sensor a real phone would have is its own kind of evidence, and it's evidence in the wrong direction. Another pattern is a straight mismatch between the claimed GPU and the rest of the hardware story. A mobile GPU family reported alongside a core count and memory figure that screamed desktop workstation, or the reverse case entirely. Those fields come from different parts of the system, so when a tool overrides one field and forgets the others, the resulting profile ends up quietly arguing with itself. A third pattern shows up in the audio hash specifically, and it's subtle. That value is supposed to depend on real hardware and drivers, so it should vary somewhat across genuinely different physical machines. If a tool just hardcodes one spoofed value instead of generating something that varies plausibly, every profile run through that tool on that one machine ends up sharing an identical hash, and that single shared number quietly links every one of those accounts together, even when every other field looks randomized on the surface. A fourth pattern is on the media enumeration side, where a profile presents itself as a recent phone, but the camera and microphone list comes back empty, or lists generic labels that don't match any real device's naming convention. Real hardware tends to expose vendor-specific device names. A blank or generic list next to a phone-shaped user agent is one more small crack in an otherwise decent-looking story. Profile managers like multilogin, GoLogin, Camelio, AdsPower, and Dolphin NT all let you configure a lot of this, override navigator properties, inject noise into Canvas and WebGL output, and adjust some of the sensor adjacent values I just walked through. That's a genuinely useful feature set, and it does real work keeping separate accounts from obviously sharing one identical device fingerprint out of the box. What none of them can do is manufacture real physical sensor data on a machine that doesn't have the sensor to begin with. A desktop or a data center server running a browser profile has no accelerometer to pull, so any motion values it reports back are synthetic, generated by the tool's own logic rather than measured by an actual chip. And depending on how carefully that synthetic data is built, it can look convincingly noisy, or it can look obviously scripted the moment someone actually checks it in a console. That's a big part of why I run some of my own multi-accounting work on real cloud phones and real proxy hardware, instead of leaning entirely on desktop virtual machines with spoofed values layered over the top. A genuine device running a genuine mobile OS produces sensor readings, GPU behavior, and audio stack quirks that are real instead of approximated. It's not a magic fix though. Real hardware costs more, it's slower to scale, and it comes with its own logistics, so it's a trade-off rather than a free upgrade. Running on real hardware doesn't make the setup undetectable, and it doesn't make any account safe from being reviewed or banned, whatever a sales page for some tool might imply. What it does is remove one entire category of consistency check from the equations, because the hardware genuinely is what it claims to be. So there's nothing for that specific comparison to catch, even though every other layer, network patterns, behavior, account history is still very much in play. If you're actually trying to evaluate a tool on this front, don't just ask whether it spoofs hardware concurrency, because almost every tool on the market does that much as a baseline feature. The better question is whether the values it reports agree with each other and with the device profile it claims to represent, and whether running that same tool twice on the same machine gives you varied, plausible readings instead of identical or static ones every time. Open a profile, check the motion output in the console, check the GPU string, check the audio hash, check the camera and microphone list, and compare all of it against what the profile says it's supposed to be. That comparison tells you more in 5 minutes than any vendor's marketing page will. None of this makes a browser undetectable, and no setup, real hardware included, makes an account risk-free, no matter how confident a product page sounds. What these tools actually do is manage and reshape a specific set of signals, and detection systems keep adjusting to whatever workaround happens to get popular. The hardware and sensor layer just happens to be one spot where the physics of a real device are genuinely hard to fake convincingly on a machine that never had that hardware in it. And understanding how the signal gets generated is what lets you judge a tool's claims for yourself, instead of just taking their word for it. I test these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectbrowser.org. Full written reviews and tested picks at antidetectbrowser.org. Go take a look and subscribe if you want more breakdowns like this one.